So now consider these recurrence relations. That is d by dx of x to the power n jn x equals x to the power jn minus 1x and d by dx of x to the power minus n jn x equals minus x to the power minus x to the power minus n jn plus 1x. Consider these two recurrence relations. By using this, we have another result. Now consider this one, first one. D by dx of x power n jn x. Using product rule, what do you get? It is x power n into j dash n, jn prime, plus n x power n minus 1 into jn. Using product rule here. So x power n into jn dash plus jn into nx power n minus 1 jn equals, right side it is x power n jn minus 1. If you divide it throughout by x power n, what it is? It is jn dash plus n by x jn equals jn minus 1. Okay, so that means from here you have the recurrence relation, so you have another relation, that is jn dash equals jn minus 1 minus n by x into j. This is another relation. Jn dash equals jn minus 1 minus n by x into jn, or you can multiply throughout by x. What you get? X jn dash equals minus n jn plus x into jn minus 1. Okay, so this is one of the important relation. Again, come to the second relation. Come to this one. So from there, what you get? If you derive this by using product rule, it is x to the power minus n into jn dash plus jnx into derivative of x power minus n. It is minus n into x power minus n minus 1 into jn equals, right side is nothing but minus x to the power minus n jn plus 1. Agreed? Using product rule. So you can multiply throughout by x power n. What is it? It is jn dash. If you multiplying throughout by x power n, that gives, it is jn dash. It is jn dash minus n into, it is minus of x power minus n into x power n. So n by x power minus 1 remains there. Jn equals minus jn plus 1. Agree? So you have another relation here, that is j dash n equals n by x jn minus jn plus 1. So this is the another relation. One is jn dash equals jn minus 1 minus n by x jn, and the second one is, it is jn dash equals n by x jn minus jn plus 1. So these are important results, A and B. Consider these two relations. Jn dash equals jn minus 1 minus n by x jn, and again jn dash equals n by x jn minus jn plus 1. Okay. So if you can add this a and b, what happens here? A plus b gives this a and b. Consider this a and b. A plus b gives a and b. If you are adding these two, on adding these two, left side become jn dash plus jn dash 2jn dash equals right side is plus n by x jn minus n by x jn are cancelling each other, and what remains there, it is jn minus 1 minus jn plus 1. That means what is jn dash? Again jn dash equals half of jn minus 1 minus jn plus 1. So this is the another important result, mark it as C. Jn dash equals the first relation is jn dash is jn minus 1 minus n by x jn. Another is jn dash equals n by x jn minus jn plus 1. And finally we have jn dash equals half of jn minus 1 minus jn plus 1. Okay. So these are our important recurrence relations. Again, we goes to another result, that is, we know by the recurrence relation d by dx of x to the power n jnx equals x to the power n jn minus 1x. This is one of our relation. Okay. So, if we integrating on both sides, what do you get? Integral d by dx of x power n jnx dx equals integral x to the power jn minus 1x dx. Okay. So what do you get? So from here, this means integral of x to the power n jn minus 1x dx equals, it is x to the power n jnx plus integrating constant c. So this is another relation. Okay. Integral x to the power n jn minus 1x is 1x dx is nothing but x to the power n jnx plus c. Similarly, you can use the second recurrence relation, d by dx of x power minus en jnx equals minus x to the power minus en jn plus 1x. Again on integration, what I get? Integral of x to the power minus en jn plus 1x dx equals, it is minus x to the power minus en jnx plus integrating constant c. So this is our two important results of Bessel function in terms of integration. Integration of Bessel functions. Integral x power n jn minus 1x dx is x power n jnx plus c, and integral x to the power minus n jn plus 1x dx is minus x to the power minus n jnx plus c. Okay. So, now we are going to another interesting result, that is, what about d by dx of, consider this d by dx of jn square plus jn plus 1 square, d by dx of jn square plus jn plus 1 square. So far, we know that what is jn dash? We have the previous results a and b. One is jn dash equals minus n by x jn minus n by x jn plus jn minus 1. Okay. And another result is jn dash equals n by x into jn, n by x jn minus jn plus 1. So these are two results, two formulas for the derivative of jn. Jn dash is minus n by x jn plus jn minus 1, and again jn dash equals n by x jn minus jn plus 1. Okay. Now, Consider this relation. So you can replace. Consider this is A and this is B. Replace n by n plus 1. Replace n by n plus 1 in A. What do you get? So it is j dash n plus 1 or j n plus 1 prime equals minus of n plus 1 by x j n plus 1 plus j. Okay, right. So now what about our requirement is this one. Find d by dx of jn square plus jn plus 1 whole square. Jn plus 1 square. Actually, d by dx of jn square plus jn plus 1 square equals it is, if you derive by usual form, it is 2 jn dash jn prime plus 2 jn plus 1 jn plus 1 prime. Okay, so here we got what is jn plus 1 prime, and here we got what is jn prime. So that equals 2 jn into what is jn prime? Jn prime is this one, the second formula, that is n by x jn minus jn plus 1. Okay, by using b plus 2 jn plus 1 into what is jn plus 1 prime? That's given. It is minus n plus 1 by x jn plus 1 plus j. Agree? So this is nothing but this equals 2 into, so 2 jn n by x or 2 jn square, 2 n by x jn square, yes, minus 2 jn into jn plus 1 plus 2 jn into jn plus 1. These are cancelling each other, and what remains there, it is 2 into n by x jn square minus n plus 1 by x jn plus 1 square. Okay, so this is another important result. G by dx of jn square plus jn plus 1 square equals 2 into n by x jn square minus n plus 1 by x jn plus 1 square. This is the important result. D by dx of jn square plus jn plus 1 whole square, jn plus 1 square is 2 into n by x jn square minus n plus 1 by x jn plus 1 square.